So as we were saying, the filters we can categorize as a passive active. Another kind of categorization is a low pass filter, high pass filter, band pass and band stop filters. And notch
Okay,
filter
sir.
is a special type of band pass filter where the band is very, very narrow. That means you can say sometimes only one single frequency can be passed, or a very limited number of frequencies, range of frequencies will be passed. That is called notch filter. Okay. Now
Okay, sir.
how to design. So let us take the simplest case, which we call as the passive filter with very
Okay, sir.
few components, R and C. Okay, resistor and capacitor will be sufficient. So how we can connect
Okay, sir.
C is the question. So one type of connection is what I am showing over here, RC. Okay, let us assume we are putting an input here, V of
Hmm.
t. Okay, Vi of t, that is the input side, and we wanted to take output across the capacitor. So let us call it as V naught of t. If you wanted to draw the equivalent diagram in frequency domain, Laplace domain, this is in
Okay, sir.
left side you are seeing in the time domain. If you wanted to draw in the Laplace domain, it can be something like this. Diagram looks same, but the notation we write as R itself. This will become as 1 by Cs, and output now is capital V naught of S, and input here is capital V I of S. Okay. So if I wanted to write the Kirchhoff's current law, Kirchhoff's voltage law, let me write Kirchhoff's voltage law, KVL. For this particular circuit, it will become like Vi of t. So this is a small v, this is also small v naught. Okay. When you are writing in time domain, these notations are small letters. When you are writing
Okay, sir.
frequency domain, this will be like capital letters. Okay, that's the understanding. General notation which people will follow. Okay, so Vi of t is equal to, assuming the current passing is I can say Ri plus 1 by C integral I dt. So if you have any doubts here, you ask me. Okay, so let us call this as equation 1. Okay, simply what we are saying is voltage raise is equal to sum of the voltage drops. That's all. Okay,
Right, sir.
voltage raise. For
Rise
example,
equal
if you
to
come from here to here, there is a voltage raise. So this is like a minus plus, you can
sum
think
of.
of at one particular instant. So this voltage raise is equal to voltage drop here plus voltage drop here. So if you consider the
Okay,
whole
okay, sir.
loop, total raise should be equal to total drop.
Okay, okay, sir.
Total raise in the voltage, it should be equal to total raise in the that same
Drop.
loop. Okay, total drop in
Yes,
the,
sir.
okay. So that is the Kirchhoff's voltage law. Okay.
Hmm.
Now let me write another equation. What is V naught of t? Okay. Output. V naught of t is nothing but 1 by C integral I dt, because you know V is equal to Q by C. Okay, this is a charge and by capacitance. Voltage is like charge by capacitance when you want to write in terms of dimensions. Okay. So V is equal to 1 by C. Integral I dt is nothing but your charge.
Okay, sir.
Because charge Q is equal to di by dt. That means, sorry, 1 minute. Integral I dt, sorry. Yeah, rate of flow of current. Okay. 1 minute, sorry, just a minute. Let me write. Q is equal to integral I dt, or you can write dq by dt. dq by dt is equal to I. Okay. So I is equal to dq by dt. That is rate of flow of charge is called current. Current is nothing but rate of flow of charge. So I is equal to dq by dt, or q is equal to integral I dt. So this is how we can define basic terms. So this is my
Okay, sir.
equation number 2. Okay. Now what will I do is, let me apply Laplace transform on both sides. So for the equation 1 and also equation 2, applying Laplace transform on both sides. So first equation is going to become like something like this. It will become Vi of S is equal to,
something happens.
yeah, I'll do it. I'll share it once more. No, you have to again make as post. Okay, right. Now it will come. Yeah. So I think it's visible to you now, right?
Not, yes, sir. Yes, sir.
Yeah. So Vi of S is equal to R times I of S. I is again capital here. Plus, now this will become like 1 by CS times I of S. Okay, that's it. Now let me take I of S.
Sir,
Yeah, tell.
V0 bracket T is then, sir, equal to 1 by C. That's our answer equation, that one output.
Yeah, output. See, output is only having only capacitor, no?
Only
See, only
capacitors
capacitor
of,
is
yes,
there.
sir. Yes, sir.
So it is like C.
Yes, sir.
That's what I told. V is equal to Q by C. V is equal to Q by C. Charge by capacitance. But Q is nothing but integration of IDT.
Okay.
Q is integration of IDT.
Yes, sir. Yes, sir.
Like that. Okay. That's all. Only one
Okay,
element
okay.
is there. Okay. Only capacitor is there at the output.
Okay, okay.
Okay. So now I of S I am taking common. This will become R plus 1 by CS. So now from here I can write I of S into RCS plus 1 by CS. Okay. So this is, okay, this is equation number 3. Let us put. Now,
CS means, sir?
S is the, okay. See, we have, I'll tell you, 1 by C integral I dt is there. Okay. This is V naught, I'll tell you, V naught of t. Okay.
Okay,
Just a
sir.
minute. Just a minute. I'll write.
No, no.
Hmm.
This one understood, sir. Here,
Ah,
VIS you said, no, sir. In that,
ah, hmm.
CS means what? What is CS?
Okay. Yeah, I'll
1
let
by
that,
CS.
that only I'm explaining. That only I'm explaining. For that only I'm writing another equation.
Okay.
There you will understand. Okay.
Okay.
There you will understand. Just what is happening every time. Okay. Zoom. Again, sharing is gone. Sharing is coming right for you. Okay, right. What happened to this?
Yeah, yes, sir.
Okay, right, right. Yeah, yeah. Delete this. Okay. Let me write. Okay. Okay. So I will explain how that CS came. Okay. For example,
Okay, okay.
if you this integration is there, no? When you do Laplace
Yes,
transform
sir.
integration, suppose I say f of t, Laplace transform you will get as capital F of S. If you have
Yes, sir.
derivative of f of t, okay, the Laplace transform for that is s into f of s. Laplace transform of derivative is s into f of s. But if you have
Okay, sir.
integration of f of t, suppose, okay, then the Laplace
Okay,
transform
sir.
is f of s by s, okay, assuming
Mm.
initial conditions are 0. Assuming initial conditions are 0. That means initially the capacitor is not charged. Conditions
Okay, sir.
are 0. Even here also we are assuming initial conditions are 0. If you don't assume initial condition 0, some extra term will come here.
Mm.
Both in the derivative and also integration thing. On the right hand side, you will get some
Okay.
extra terms for both of them. Okay. If initial condition, that means
Okay, sir.
initially the capacitor is charged. Already there is some charge in that, means some extra terms are coming. Now I am assuming no initial charge. So this much will come. Okay. How this came?
Okay,
If
sir.
you want that derivation, I can tell you. For example, I'll just come down slightly. And just to scroll down slightly, I can explain you how that came also. For example, Laplace transform of f of t. Come to the basic 0 to
Okay,
infinity.
sir.
I am coming to the basic definition of Laplace transform. Okay. Now I want Laplace of d by dt of f of t, suppose. Okay. So this we are calling as
Okay, sir.
f of s. Okay. So now this I have to write as 0 to integral d by dt of f of t e power minus st dt. Okay. So
Okay, sir.
if you do manipulation for this, okay, so you can show that this will be equal to s times f of s. Okay. So how to do that means I'll explain that
Hmm.
also. Just a minute. Give me some 1 minute of time. Right. Yeah. So what you do is differentiate. Yeah.
Just,
Ah,
I understood,
you
sir.
understood that part, right?
It's
Yeah. Hmm.
it's difficult to
Okay.
understand.
Ah.
Yeah,
Okay.
you
This
just
part you
tell
understood.
me with the values, sir.
Ah.
Yeah, you just tell me with the, I forgot all
Yes.
Laplace transform this one, sir. I will
Ah.
once
Yeah. Yeah.
again go through, sir.
Okay. So okay
Just
then.
tell me with some values, sir.
Yes. Yes. That I will
If
tell.
we
That I
give
will.
5 volt, what will
Ah,
be the
yes.
after filter
I
like
will.
that? You
I'll
just
tell. I'll tell them. I'll tell them. First, no. If you know the general equation, then we will substitute values. Don't worry. So that's how we got up to
okay,
this level. Okay. So this part.
okay,
So that 1 by cs why it came means because of this formula, which
yes, sir,
I have
yes, sir.
explained here. Integration is
Okay,
there means that. Okay.
okay, okay,
Now same way here also when I apply Laplace transform, this is going to become like V naught of s is equal to I of s by cs. This c is like that only. Integration I has become
hmm.
is by s. Okay, like f of s by s.
Okay,
Okay.
yes,
Again, initial
okay,
conditions are assumed 0. Assuming
hmm.
initial conditions equal to 0. Okay. Now, this
Okay,
is
sir.
equation number 4. Now, from this, I can substitute using 3 and 4. Equation 3 and 4, if you use, I will substitute I of s. I of s is nothing but, I will write V I of s is equal to RCS plus 1 by CS into IS. Instead of IS, I will put
Hmm.
this CS into V naught of S. Okay.
Okay, okay, okay.
Now this CS will cancel. Now this will become, V naught of S by Vi of S, which we call as transfer function, output Laplace by input Laplace with initial condition
Okay,
0.
sir.
With initial condition 0, that we call as transfer function. Generally, we write as H of S, and that is equal to how much? That you can check clearly. 1 by 1 plus RCS. Okay. Now, if I
Yes.
put limit s tends to 0, H of S, this will become 1. You can see. Just to substitute S is 0. What will come? 1 will
Okay.
come. And when I put
Hmm.
s tends to infinity, H of S, this will become limit s tends to infinity 1 by 1 plus RCS, that will become 0. You can see if I put here infinity, the denominator will become infinity. 1 by infinity is 0, right? Like that.
Yes, sir.
Now, but what is S? S is nothing but complex frequency. S is nothing but complex. Oh, sorry, one thing we forgot. I think we forgot to record. Just a minute.
So recording only, sir.
Recording. Okay, going on. Okay, so S is nothing but complex frequency. That means it is nothing but sigma plus j omega. This omega is the frequency. Sigma also is frequency. This is real part. This is imaginary part. Now,
Okay, sir.
okay, right? So that means S tends to 0 means low frequency. This is low frequency. And S tends to infinity means high frequency. Now you can see at low frequency you have 1 and high frequency you have 0.
Hmm.
That means it will not pass high frequencies. It is 0, no? So it will not pass that high frequency. That means this is low pass filter. That is what we can tell. So this
Okay.
circuit diagram is low pass filter, cutoff frequency is FC suppose, and this is normalized, okay, na, output, normalized output, okay, na, I can say normalized. Okay, so ideal filter will have this kind of characteristics. Perfect one means normalized value, and perfectly it will become 0 after FC. But practically, it will not be like that. Practical filters may have this kind of approach. Okay, as it is going to infinity, this value is tending to 0. That's all. Okay, no? Tending to 0. And it
Low pass means
uh,
it will allow
low
only
low frequencies.
lower frequency.
Yeah. So at low frequency, this is again F. Okay. So this is a practical filter. Practical filter. This is ideal filter. Okay. Ideal filter, it will
So
be
low pass is
both are low
like it
pass.
will allow only low frequency.
Yeah, that is right. Low frequencies means, yeah, see, this is a low frequency area. So this is low frequencies, it is passing. If it is having high value, it will pass that frequency. That is the meaning. If it is having low value, it will not pass that.
Okay.
See, this is nothing but
So
magnitude
low value will
response.
not come now. Sir.
That's what in low pass
No, no, sir. I'm
frequency.
telling like
Uh,
low pass frequency, lower bandwidth will be omitted or
it will be passed. It will pass. It is not omitted. It will pass the low
output will be
frequency.
coming. Yeah.
Output will
Okay,
come.
okay.
Low frequencies, if you are passing, it will come at the output.
But in high pass filter, if we put high frequency will pass or
In high pass filter, only high frequencies will pass.
okay,
If
okay.
you say high pass filter, high frequencies will pass, other frequencies will not pass. This is magnitude response.
High frequency, which what value we are given, the filter will pass more than that value, not
Yeah.
below.
Yes, not below. If it is high
Okay,
pass filter. Hmm.
okay, okay, sir.
So I'll write here, low pass filter means it will pass frequencies below
Below set
FC.
value.
Yeah, below, yeah, FC cutoff
Set value.
frequency. High pass is,
Okay, sir.
it will pass
Will pass frequency
frequencies
above FC.
above FC. Okay, right. That is what you have to think. Okay. Now,
Okay, sir.
so this is what low pass filter is. Now I will try to draw for more accurately. Okay, whatever I have drawn is a rough estimate kind of thing. Let me draw in a more better way. So for example, let me do in the time domain, same thing. Okay, if I do in the time domain, what will happen? Let us see. We have V naught of S is equal to 1 by RCS plus 1 times Vi of S. This I will rewrite. Let us take impulse input. Okay, impulse input. When I say impulse input, H of t will become, let 1 minute. When I say impulse input, my Vi of t will be, Vi of t will be nothing but delta of t, impulse. Then Laplace transform, that is Vi of S. Laplace transform of impulse is simply 1. I am applying Laplace transform. Laplace transform of impulse function is just 1. So
Okay.
now what will happen is, this will become like this. V naught of S is equal to simply RCS plus 1. Okay, na? But whenever you are giving input as impulse, output we will write as H of S. Because when the input is H of t, when the input is delta of t, the output itself is
Okay, sir.
becoming H of t. Why
Okay,
means,
sir.
why I'll tell you. Because Vi of t convolution of H of t, input convolution with H of t is nothing but V naught of t. When I apply Laplace transform, this will become V naught of S into H of S equal to, VI of S, Vi of S into H of S is equal to V naught of S. So, but here in this example, H of S is equal to 1. Why H of S is equal to 1?
Yes.
That is uh, because I took input impulse as input. Okay. So H of
Yes.
S is equal to 1 here. So, okay. So just a minute. When it 1 minute, just 1 minute. Not H of S is 1, VA of S is 1. Sorry. Okay. Not because we have taken VA of T is delta of T, not H of S is 1,
Okay.
but VA of S is 1. Okay. Okay. So that is
Within
why.
10 minutes, the meeting will over, sir.
Yes. Okay. So VA of S is 1. That is why when VA of S is 1, what you got simply V naught of S is equal to H of S. That is what I have written here. Okay. Now, I am recording. That's why you can again go through later on also for cross checking. Okay.
Yes, sir.
So H of
Yes,
T.
sir.
Now let me take inverse Laplace. Inverse Laplace. If you take, how to take, that is a question. So this will become like, I can write, I am taking RC outside. I am taking RC common here. So this will become RC, 1 by RC itself. This will become e power minus T by RC UT. You can write like this. Okay. So y means I'll tell you.
Okay, sir.
Y also I'll tell you. If you have suppose u of t, which is called unit step function. For unit step function, Laplace is 1 by s. If you have e power minus alpha t ut, then the Laplace transform is 1 by s plus alpha. Okay. So now this is also in the form of 1 by s plus alpha. In the place of alpha, you have 1 by rc. So this is a standard formula. We should also write region of convergence. Okay, na? Here the region of convergence is real part of S is greater than 0. That is how we generally mention. Okay.
Okay.
Okay. So every time you have to mention that ROC. So with that
Okay.
understanding, this is the answer. Now I will draw the graph.
Mm.
If I draw the graph for this, I am going to draw the graph for this. This is in the time domain. Now I am drawing in the time domain. In the time domain, we are giving suppose impulse input. Okay, impulse input. Okay, let me also draw on the negative side. I will put another color. My input is this. Okay, delta of t.
Okay, sir.
Here I will write both input and also I will write output. I will draw both on the same thing. Now output, how it will look, that is a question. You can see clearly when I put a t equal to 0. Now this u of t is there, no? What is u of t? U
Mm.
of t is nothing but it is a step signal. That means up to 0 it is 0 and after 0 it is 1. This is u of t, unit step signal.
Yes, sir.
So below 0 it is 0 and after 0 it is 1, right?
Mm.
Okay. So here, what now you wanted to draw this diagram. You are drawing this diagram basically. Okay. So
Mm.
t, when you put it less than t less than 0, the left hand side is all 0. Output is 0 because you did not give input. On the left side, you did not give any
Yes,
input, so
sir.
it is 0. And now after at 0 and after 0, what is going to happen? If you put t equal to 0, this will become e power 0, that will become 1. Simply you will get 1 by RC. Okay. And for
Mm.
easiness, you can put RC equal to 1 also. If you want to, not compulsory. If you put,
Okay.
I am not saying it is compulsory. If you put RC equal to 1, which is time constant, then it will become simply
Mm.
e power minus t. Simply the whole thing will become e power minus t ut. So the graph will look something like this. As a t tends to infinity, it will become close to 0, like that. Okay.
Yes, sir.
So this is the output graph. The black color is the output graph. Okay.
Mm.
Yeah. And already input you are able to see there. Okay. Like that.
Yes, sir.
Yeah. So this is how the low pass filter will have thing. Next, for high pass filter also you can do very similar
Sir,
thing.
can we, sir, can we use same RC for high pass filter, sir?
Yes. That I will show you now. Because I told very slowly the low pass filter. Now high pass filter will become very fast. Now you can use it as high pass filter by putting like this. Here it is the C, here it is R, and here it is now V naught of T. This is VA of T. Okay. So here again, let me do the similar analysis. I will not write all steps now. I can write very quickly now. I will write VA of T is equal to 1 by CS. Sorry, I am writing in time domain. So I have to write slightly differently. 1 by C integral IDT.
There you said no,
Yes.
sir.
Yeah.
Voltage rise is equal to sum of voltage drop in the
Yeah.
previous one, sir.
Yes, the same thing here also.
Here,
Here also, voltage rise. Always, that is a universal fact. Always see if you are getting how much you can spend, how much a person can spend, only whatever he has. That's all, right? So, how much you can spend, how much this voltage source can spend means that will be equal to how much it can actually, how much it actually
yes,
has.
sir.
That is, hmm,
I will coming, sir. They
hmm,
are charged by capacitor. That
hmm,
one is
hmm.
a low pass filter.
Yeah.
Yeah, high pass filter is what is that, sir?
Here output we are taking across the resistor. See, the where we are
Resistance.
taking output
So,
will decide whether it is high pass or low pass. So here the first equation is again same. You see,
yes, sir.
first equation is same, but second equation will become different. V naught of t is equal to R times I of t. Okay. Now again apply Laplace transform for both. So I will write slightly quickly. V1 of S is equal to I of S into, like what happened earlier, this will become 1 by R I of S times R plus 1 by CS. That is equation 3. Again, initial condition 0. That will let me write 0. Okay. Then V naught of S. This will be important. R times simply I of S. Okay. So now I will use equation 3 and 4. From 3 and 4, I will divide 4 by 3. When I divide 4 by 3, I will get like this. V naught of S by VA of S is equal to R by R plus 1 by CS. That is nothing but, okay, RCS by RCS plus 1. Okay. Now, if I take RC common, it will become like 1 by this, like this. Yes, sorry. I'm taking RC, right? S plus, it will become like this. Okay. This is your output. Okay. Now,
Okay, sir.
yeah, that's all. This much you get. Now, here also you can again use that same technique, whatever I told, like converting into time domain and drawing the diagram. Here, if you put limit S tends to 0, if you put S tends to 0, this will become like 0 by 0 plus this is 0. That means low frequencies will not be passed. Because see, what you are drawing, this is nothing but magnitude response. Magnitude itself is becoming 0. Magnitude is becoming 0 means that will not come in the output.
Okay.
Okay. That is how you have to understand. Now, when I put S tends to infinity, this will become S by S plus 1 by RC. Now, this will become like infinity by infinity, L hospital rule. L hospital rule we have to use. When you use that, we have to differentiate this with respect to S. It will become 1. And here also we have to differentiate with respect to S. This will also become 1 by using L hospital rule. So final answer is
Okay.
1. 1 means big number. It is not 0. That means it will pass. It will pass high
Okay.
frequencies. Okay, now time is over almost. Okay, if you want, we will continue.
Sir, only we'll continue, sir. Just a minute, sir. I'll just noting down.
Then I will send the link because you
Only one thing, sir.
are.
Now we will continue after some time, sir. Maybe when you are free or evening time when
Okay,
you go
your
to
wish.
home.
Okay, then. Now we will stop then. Okay, then. Nandri.
Only one thing, sir. One thing, sir. Instead
Tell
of
us.
using instead of using resistance, can we use inductor, sir,
No,
in
resist.
the low pass filter?
What you want to use? Inductor.
Inductor.
Yes, you can use
Yes.
inductor. I will tell with inductor also. Not with, see, resistor we will use instead